Okay, so that is done. And now we can try to work on establishing our camera first, because we want to take a look at through the camera and see the base this way. And when we have the object and camera aligned, then we can work on materials and then we can work on lights. Okay, so let's go to Blender. And there's the tag. The tag is on the left side, exactly the same way like in the image. And we can create a camera. So there's our camera. The camera is incorrectly positioned and rotated, so I can turn on the move command, move it further away. The icon is way too big, so we can press S and scale it down, make it tiny, very good. And then I set this rotation here all to 0, very good. I can move the camera up a little bit. I could rotate it. Currently the camera looks down, it has to look at the device, and that is the x-axis. So let's rotate it, very good, there. And to take a look through the camera, we can click the camera icon, but then we can't see the rest of our scene. So let's click this icon one more time. And we'll slice the interface. So we have the camera here, and then here our 3D space. T and N, clean up that space, zoom in a little bit. There's that stuff, very good. Now, during class, I mentioned the difference between global and local, and this is a really great modeling function in Blender. It also has normal and other stuff. Alias from Autodesk offers the same. With global, Z is straight up, Y is straight horizontal, same in X. Because our object is rotated, if I click local, you see now Z is actually the viewing axis. So I can slide it towards or further away, and Y is now up, but at an angle, based on how that object is rotated. So in this case, the local orientation is much, much better for manipulating and moving these objects. And I can also turn on the rotate if I want here, there. Sorry, not rotate, I meant turn on the transform. One question, can we not have both turned on? No, that doesn't work anymore. It was a previous version, so we can use transform. Very good. Before we continue, we want to see the background image inside our camera. So with the camera selected, so here it's selected, then we go to the properties buttons, click on camera, go to background images, turn this on, add image, open, and then we navigate to where our project folder is, render targets. And purposely, this is what you see first. These 3 icons here give you a list with more data, and then a thumbnail preview. That image we want. Open. And that image looks a little bit distorted. And that's because it has the wrong proportions, or meaning our camera has the wrong format, so the image is being stretched. I will go to the desktop for the moment, Command I, and it tells us this image is 727 by 494. So copy this one. Let's go back to Blender, and we have to adjust the image size. To do this, we can go to Output. Here we can specify the proportion. So 727 by 494. There we are. Now this is perfect. Very good. I go back to the camera because we have to mess around more of the functions here. Before we continue, we have an alpha slider that makes the image more or less transparent. And we have the ability to show the image in front or behind the geometry. Now, because we want the camera to move and rotate so that the geometry matches the image, it's better to show the image in front. And then we play with the transparency so you can see easily these two parts. And our 3D model looks like a ghost image, and all we need to do is to match it. So matching, how do we do this? Probably one of the first logical steps would be the Roku is more on the right side. It's not really centered, so I have to move my camera so it's centered like this. Okay, then the image is, the Roku device is too small, so I need to move my camera closer and then maybe move it to there. Okay, the angle is also not correct, so I changed the rotation and maybe a little bit more there. Then I move this a little bit to there. And then, wow, why does this corner not look like this? That's because while actually in the photo, the Roku device is more to the left, that's not the way how we can render it. The camera still has to be perfectly in front because this and this edge are very much the same. This is actually not the original image. This image probably was much bigger, and they just cut off the left side, which means the camera has to maintain centered in front of the Roku device. I move, in my case, it left and right, and I see the X value being changed. So X is 0. In some people's case, it might be Y. Very good. So now how do I get the Roku device to the left? And welcome to the shift of the canvas. If we go to the lens, here we can shift it. You see in the icon how this actually changes. And the perspective distortion does not change. We simply kind of like keep the camera where it is, just shift it. So the left and the right perspective effect maintains the same. Unlike when I do it this way, you can see how my device really is being distorted to the left and the right. So that in a nutshell is what the tilt shift is doing. There. But now our side edges are not the same. Can go to your side view. This actually is what I do very often, and I press R to rotate, and then G. Nope, this is too deep. R and G up. Yeah, so this is getting better. Okay, I still can't get these corners filled, and that is because this camera currently uses 50mm focal length. The photo or the rendering was done with a higher value focal length. Just to explain this, what this means, I put this to 21 and I get closer and you see, wow, it's like a fisheye. To the front, it's really wide, and to the back, it is really distorted. The opposite, 100, is more like a telelens, so we are losing perspective for shortening or the distortion. We're getting closer to the way how maybe an orthographic image could look like. And well, there we are already, pretty close. So you see the edges line up, maybe top and down a little bit more. Yeah, that's pretty close actually. Yeah, put this in front and turn this on off so we can just compare. Yeah, we're pretty good. And that, in a nutcase, is what is called camera matching or mapping. We have, in this case here, just an object, and we need to figure out where was the camera in terms of position, rotation, and then also the focal length. And then here we have all the tools for the length, shift, position, and rotation to adjust this. Now, these values are specific to my scene, but in everybody else's Blender file, these values should be very, very close. I just noticed there, my object is a little bit too much on the left. So no, actually it's not enough on the left. So zoom in a little bit more. There we are. Very good. Okay, goody. Next video. Kidding.